Hello. Good afternoon, everyone. Happy weekend. Today, we'll proceed in our mathematics class, and by God's grace, what I will just do is I will try and split the teaching in a way that it will accommodate both presentation of materials and solving of problems. So, we are going to make the class a bit uh, interesting today. Okay. So in our class, we started with decimals, approximations, fractions, logarithms, sorts, indices, number bases. We've done all of that. I think today we should quickly move to set theory. So we'll be doing set theory today. Set theory. Okay. So that's what we'll be doing today. And then for today's set theory, there are some things we need to know. The first set of things you need to familiarize yourself with is the notation. How do you do the notations, or what do you know under set theory? Okay, so we are going to bring up the notations and their meaning. I may not be able to write everything word for word. For anyone that is preparing for JAM mathematics, that person must have at least gone through 3 years of secondary school mathematics. So it's more or less like we are just repeating the same thing. Just that at the level of JAM, there are ways that the topic or the questions become a bit tricky. So we are not actually teaching set theory from the scratch. No, we are just building on what you need to know. So by reason of that, I will just list all the notations out, then I will tell you what it is, then we can quickly move on. So here, or this is called universal set. Yes, it's either any of those two. This one is or. So let me just rewrite it, or probably slash it. But I don't want it to look like whether this or this, something that looks like that is called universal set. And then we have your intersection. This one is common. Everybody will know what intersection is. I'm just trying to make sure it boldens up. This is intersection. You have like this. This is union. Okay, you have something like this. And I want you to note this. You can see this E is quite different from this E above. The design is quite different. In fact, sometimes some people just do something like this. It is called element. It is called element. Element. Okay. Let me just do the whole thing. A kind of small C with, so it is called element. Then when you have a, when you have a is this. Now I'm going to explain this. This small letter A is referring to element, while capital letter A is referring to set. So a set is classification of distinct objects. So when I say set of cars, you have several cars that can be in set of cars. I can also have what we call set of sports utility vehicle. You can have set of saloon vehicle. You can have set of, different types of cars. Those ones are called subsets. Now, when I have something like this only, it is called subset, either this or this. Okay. One is called subset, one is called proper subset. And I think the details of whether it is subset or proper subset is not actually still needed, even at JAM level. It is only when you want to pursue, or probably you are a student of further mathematics, then you understand proper what subset and proper subset means. All right. A proper subset is just a subset that is contained, totally contained, or that is equal to. So in this case, this one is called proper subset. Proper subset. While this one is just referred to as ordinary subset. Okay, but don't worry, we may not be able to discuss the details of that. But in case they give you both, you just still interpret it as subset. Okay, now let's go to the next one. When you have something like this, It is called a complement. A complement. It's either this format or this way with just a kind of, let me do it properly. Something like this with a line, kind of what do you call it? So it is called complement. What is a complement? A complement is actually the set of elements that is not in that set but can be found in the universal set. So if I'm referring to a universal set as set of cars, and I'm referring to a set A, capital letter A, as part of the set that is universal set, that's what called a subset. Okay, sub means part of, smaller part. So set of SUV cars is A. Now, if I want to refer to another set that is called a complement, it means that all other cars that I can find, but they are not SUV cars. We have designated A as set of SUV cars, but A complement will now be set of cars that are not SUV cars. I'm going to demonstrate that in a bit too. You will understand that. Now, we have this notation going back to the subset issue of subset. So I can have something like B is a subset of A. That's the interpretation. B is a subset of A. The converse is that A contains B. Something like this. It's just like forward and reverse. When you say B is contained in A, then you can say A contains B. So both of them are just reversing the statement. It's not negation, reverse. Okay, you reverse this, you tell this in another story. Dele is my younger brother. Okay, Dele is my younger brother means B is contained in A. So the statement B is Dele. Now, subset means my younger brother is I contain it. That is, now I can say I am the elder brother of Dele. We are just reversing. Is the statement is just the same thing. So as not to give you so much confusion. So you note that. Then the next thing is that presentation of sets. Sets are presented in three ways. Presentation. Sets are presented in three ways. Sets are presented in three ways. The first one, I call it listing form. You list all the elements of the set. Second one is called the builder form. Builder, like you are building something. Then the third one is called the Venn diagram, diagram notation or diagram representation, as the case may be. Diagram. But the diagram has a particular name. It is called Venn diagram. Venn is the name of the man that invented the mathematical aspect of set, the diagrammatic aspect of set theory. The man is called John Venn. John Venn. So we decide to honor him with the name of the diagram being named after him. Venn diagram. Venn diagram. Don't mind my writing, please, but just follow the explanation. You'll be able to get everything properly. So I said the listing form, the builder form, and the Venn diagram form, which is the diagram aspect. So let's go to the listing form. And then in this case, you have to listen very well because there are some very, very important things under set theory that we're going to be talking about. So for number one, the listing form. They will give you a set, and this one is the easiest part. Is the easiest part. They will give you the set. They will tell you what you are supposed to know about the set. Every element of each of the set will be given to you. So let's say universal set is the set of all odd numbers from 1 to 30. That is, in this case now, they are not just giving it to you, they are giving you the exact value. 5, 7, 9. Maybe I should stop at 20 because of space and time. 1, 3, 5, 7, 9, 11, 13, 15, 17, and then 19. Okay, so let me just stop it at this. And then they are now telling you that you have a set A. You can see they are listing everything out for you. Maybe odd numbers between 10 and 20. So set A is 11, 13, 15. Sorry, 15 I wanted to write. 15, then 17, and then 19. So that is set A. Set B can just be, they can just give you something, it doesn't matter. 9, 15. They will just have something like this is 15. And then set C, okay, maybe I should just stop here and then work with this little one because of space. So this, when they list everything out like this for you, then the next thing is to work on yourself. Begin to work on yourself. We can talk about A union B. We can talk about A complement. We can talk about A intersect B. We can talk about B complement. We can talk about a lot of things that we can discuss under this. But our joy is that everything we need to work with has been given to us. So the listing form is what you have here. Now let's go to the builder form. In that of the builder form, they will not give you what you need though. They will only give you a precise information that will lead you to what you need. A precise information. So something like this, they can say your universal set is equal to x such that 1 is less or equal to x less than 20. Something like this. And then probably they will give additional information that x is n. And I think when I started this class that time, the first set of thing I did was to define numbers for you. I defined numbers. So let me interpret this. X is an element which belong to a universal set. And they say that x is 1 is less or equal to x, but x is less than 20. And then the additional information here is that x is in n. This n simply means natural numbers. Natural numbers. So when you see n in this format, they are trying to tell you this is natural number. So all natural numbers, what do you understand by natural number? Natural numbers are numbers that are whole number and positive. Positive whole numbers are called natural numbers. So this is builder form. So when you are given something like this, you are the one that will have to write out the exact numbers. They didn't tell you what numbers they are telling you. They just gave you something to work with. So you are now going to build. It's like you have been given water, sand, and cement. Build a house. So you are the one that will now list out. So you have to list out what these exact values are, which are, of course, 1, 2, 3, and then you continue like that until you get to 19. You will notice that 20 is not part of it. Why? Because that number must be strictly less than 20. So you must not cross to 20. You must stop at a number less than 20, which is a whole number. Whole number, positive number. So this is the answer to that form. So they can give you something like this. The subset of u, okay, they can tell you you have something like, okay, I can give you anything, just, multiples, as simple as that can be. Multiples of 3. Don't forget, in this case now, you have to be careful. I deliberately set it this way, looking like it's an half information, but it's not actually. Your universal set is the number one consideration you need. Your universal set that all the numbers you need must be between 1 and 20, like from 1 to 19. So now, this particular set they are giving you, is not a new set entirely. It's actually a part of the universal set. Universal set will give you the demarcation of what the set of what the discussion is all about. So you are not expected to travel out of that demarcation. So it's like when you say Lagos and then you are talking about Magboro. Magboro is not Lagos. It's a new part outside Lagos. So if I have Lagos and I'm talking about Maza, I'm talking about Ikeja, I'm talking about Lagos Island, I'm talking about Lekki, I'm still in Lagos. But anytime you now say Abeokuta, Abeokuta is not part of Lagos. So it's a new set entirely. So when they give you a set, okay, let me give you another one. Nigeria is a universal set. So everything I must be talking about Nigeria should be everything that is contained in Nigeria. If I say Nigeria and I'm talking about Cairo, Cairo is not in Nigeria. So you are discussing a new set entirely. So you have to mind the boundary. So when I say multiples of 3 now, don't be thinking I'm talking about 3, 4, 5, and then 21, 24, 26. You'll be going out of this universal set. So you need to learn to contain yourself within. So the solution to this now, my A will just be all the multiples of 3 that are within this bracket are 3, 6, 9, 12, 15, and then 18. These are the multiples of 3. Okay? JAMB can be this funny because they will not tell you multiples of 3 less than 20. If they are nice, they can say that, but most times they are not always nice. That is why most students fail mathematics in JAMB. You have to be very, very mentally alerted to be able to know, because they will just give you that information as if it is not relevant to what you are doing. No, you have to on both sides, and I can tell you very vividly, all JAMB questions, maybe with the exception of one in 1980 something, maybe one or two. But I can tell you in the past 12 years, from 2010 at least so far, all their questions have answers. All JAMB questions have answers. So most times you work with, you say there is no answer there. There is nothing like that. JAMB made mistake. No, most of the questions they are giving you have been tested, retested, and subjected to different answer tests. They deliberately do that. In fact, most times they will give you instruction to 3 decimal place. You'll be seeing answer of 4 decimal place, the same answer, and then you pick it. You are wrong. So all these things you have to mind them, and that's why I'm saying today now I'm going to make the teaching a bit short so that we can work with questions. Really, it's good that we work with questions for today. And so today now I've been able to say some things. In this case now, let's assume they want us to have a complement for this now. I've told you that a complement is what is not in A but can be found in universal set. So every other number that is not including these ones are the complement of A. So we can list them out as 1, 2, 4, 5, 7, 8. Then we talk about 10. 10, I can list on 10, 11, 13, 14, 16, 17, and 19. Those are A complement. So in this case now, I will just put dot, dot, dot. I'll probably stop at 19. Look at what I will do for you now. So here it will be 1, 2, 4. I want to just continue like that. Then I'll put 19. All right. So you will understand what numbers you should fix there. 1, 2, 4, 5, 7, 8. I've just said it now. 10, 11, 13, 14, 16, and then 17 are the dot, dot, dot that is missing. So if you fit it in, that is a complement by default. All right. So let's quickly move on. Now let's talk about, okay, these are the work we've done so far. Let's talk about working with intersection. Then there is something I want to give you before then. Let me talk about this, something like this. This is called cardinality. Cardinality simply means the number of elements in a set. So if I write A in bracket, that's, I'm talking about set A, then the N you are seeing before the bracket is the number of elements in this set A. So let's go back to the previous session. This one now. For our set A, how many elements can we count in it? Let's count together. I have a 3, I have a 6, I have a 9, I have a 12, 15, and 18. That's 6. 6 elements in this set. So definitely it will be easy for me to say that n of A is equal to 6, which means the number of elements contained in A is 6. The number of elements contained in A is 6. Okay? I just want to give as much information as possible here so that it will be easy for us to deal with some other aspects. We can't finish all these things today. Yes, we can't finish in a lecture, but I will try my best to make sure that at least the little you are able to push it through. Now, let's talk about supersets. There's something called superset. Let me assume that we have set F, which is 1, 2, 3, 4. This is a set. Don't, okay, so I need to let you know this. Every set is written with capital letter, while if you are using letters anyway, the element of the set are written with small letters. That is if you are using letters. But if you are not using letter, you may not bother yourself about the case of the letter. If you are not, in this case, I'm using 1, 2, 3, 4. I can decide to say set G. You can give it any name, A, B, C, D. All right. But always make sure that you are separating those elements with a comma. Yes, you can see that I've been separating my elements with comma. So now, these are not equal sets. These are just equivalent sets. F and G are equivalent. What do you mean by equivalent? The number of elements in each of them is 4. They have the same number of elements. All right. So they are called equivalent sets. But equal sets, please note that it is very important that it is not everything we can write down. All right. Especially that I'm not using slide. It's not everything we can write down really. So, but if you pay attention to the thing I'm saying, you will actually get it. Now, these are equivalent sets. They are not equal. Assuming I have another set H, E, F, G, H. Okay, let me say I have set H now. That gives me this 4, 1, 3, 2. Okay, this one now, and it doesn't matter the arrangement of the set because that confused students. I deliberately set it this way. Set F and H are equal sets. F is equal to H because it contains the same number of elements and it contains the same element. So they are the same element. I have 1, I have 1. I have 2 here, I have 2 in H too. I have 3 in F, I have 3 in H. I have 4 in F and I have 4 in H. So these are called equal sets. Two sets are equal if they contain the same elements and the same number of elements. All right. Now, assuming that in this H, I decide to repeat 4 twice, then it is not equal to F again. They have the same element but not the same number. Now if you want to count the number of, assuming because I've not actually done that. Okay, let me make a case for another set. Then let me call it set I. In this set I now, I have 1, 3, I have 3 again, I have 2, then I have 4. All right, so set I is not equal to H and set I is not equal to F. 3 is repeated twice. It's the same thing, but because if I want to find n of I now, n of I is not 4, n of I is 5. The number of elements contained in I is actually 5, not 4. Not 4. All right, so please note that I is not equal to H. It is not equal to. The number is not. But F is equivalent to G. H is equivalent to G. They have the same number of elements, but they are not equal. H is not equal to G. I've said that earlier. So that one is sorted. Now, why did I have to say all of this? Now, let me go to what I call supersets. A superset, maybe I should take it more gradually. Okay, let me introduce some concept before I go further. Let me talk about empty sets. You should know what empty set is anyway. Like I said, you don't expect me to give you uh, all the details of the prerequisite, which you already knew, like 3 years down the line. So an empty set has a symbol of this manner, or you just have two curly brackets with nothing inside. Don't write the two together. Please note. Some of you get confused by writing something like this. It's confusion. Oh, this is not empty set. When you write something like this, it's wrong. Oh, let me use bread biro. It is either not combine the two together. So this is very wrong. You cannot combine the two together. All right. So pay attention to that. Now, this empty set has a unique characteristics. What do we mean by empty set? Empty set simply means no element is contained in that set. And I'm going to give an example. Yeah. So assuming I have a basket, maybe I have 3 baskets. Let me call it ABC. One basket contains 2 oranges, the other basket contains 3 apples, and then the third basket, ABC basket, don't forget, oranges, apples, and then in the third basket, there is nothing. So automatically, I can use those baskets as sets. So in the third basket, there is nothing means it's an empty set. It is possible to have a set that is empty. Very, very possible. It's very possible to have a set that is empty. And I can give you situation where you can have a set that is empty. Let's look at set G. Set G, okay? In set G now, let's assuming that I want to list all the subsets of set G. If I want, and I'm going to do that, I'm going to list all the subset of set G in the next board. So I'm taking this to the next board now. So I have my set G as A, B, C, and then D. Okay. So list all the subsets of this set G. Now, this set G contains 4 elements. Then the number of subsets you can get in this set G is 2 raised to power n, where n is the number of elements in that set. So in this case, the number of subsets will be 2 raised to power 4, and that's equal to 16 subsets. So I'm going to get 16 subsets from this set. 16 subsets. Now, what are the major things you need to know about listing the subset of a set? Number one, empty set is a subset of every set. I come again. Empty set is a subset of every set. Empty set is a subset of every set. All right? That's all you need to know. Even if it is an empty set is a subset of itself. An empty set is a subset of universal set. Empty set is a subset of every set. You need that information. Now, every set is a subset of itself. I come again. Every set is a subset of itself. So we have 2 things that we note there. So let us list all the subsets of this set. Anytime you are listing a set, don't forget that it has to be accompanied by the curly brackets. So let's go. The list of subsets of set G will now be, we start with empty set. I can actually do this. Then we pick the entire set. Not one now. A, B, C, and then D. Okay, so I've already used 2 stones to kill a bird. The first thing I did was I stated the universal rule. Empty set is a subset of, so empty set is a subset of G. G itself is a subset of itself. Now let us list every other subset. And then here we are going to have A as a set. We can have AB as a set. We can have AC, of course. We can have AD. Then we can now have ABC. We can now have ABD. We can also have ACD. ACD. Okay. We can also have, let me see, how many do we have now? 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we are still going on. Now, what can we have? ABC, ABD, ACD. Okay, we can have BCD. Yeah. BCD. Then we can now have B as a set on its own because we stated A as a single set. And I'm going to tell you that is another thing we need to know. When you have a set with one single element, it is called a singleton. Then we have this. Let's count now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We still have 3 more to go. Let's look at it. A, B, A, C, A, D. Do we have BC? We don't have BC yet, so we go for BC. BC. We go for BD. BD. And I think the last one is CD. Separate, then we have C, D. So this is the entire set. Let's count now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. So the set of all the subset of elements that we have here is called the superset, or what we call power set. Is that you call it superset or you call it power set? So these are the list of the subset of set G. Subset of all the subset of set G. All these ones are sets that are part of set G. They are set on their own. So these are all this. You can see now, if you see what I did, 2 raised to power n. N is the number of elements. So it means that if we have a set that is 5 elements, then what you are going to do to get the number of subsets is to say 2 raised to power 5, and that will give you 32. And we will be able to list them out. I want you to try that on your own. Give me a list of elements. Give me a set that has a list of elements like 5. Then, of course, work out the number of elements, the number of subsets. Then you'll be able to try and list out all the subsets. If you are, if you are smart, you'll get everything right. So that is it. Let's quickly consider in the next less than 10 minutes. Let's consider some examples from JAMB book. I've already instructed that you can send in your questions. I've already instructed that you can send in your questions. So next class, we'll be discussing the diagram part and then some calculation involving set, the algebra of set. I have not stated that today. I think those are the 2 things we need to concentrate on next. Algebra of set. What I meant by algebra of set is there are calculations involved in set theory. Yes, there are calculations involved in it. Look at this question. Okay. They say that A, these ones are just subsets anyway, is equal to 1 less than y less than 6. Okay, and then B is equal to prime numbers less than 10. Prime numbers less than 10, then C is equal to even numbers from 1 to 10, even numbers from 1 to 10. That's the question. The question now says, question, what is A intersection B intersection C? This is the question. If you want this, you cannot easily get it right if you don't write each of these elements out. So you can see now what they gave us is just builder notation. They didn't list the elements for us. So we are the one that will now list the elements. They didn't list it for us. We have to list it ourselves. Okay, so to be able to solve, let's first find each of these elements out. So 1 less than y less than 6 means you have to start from 2, 3, 4, and then 5. Then for B, prime numbers less than 10. What are prime numbers? Prime numbers are numbers that has only 2 factors. 2, 3, 5, 2, 3, 5, 7, and that's all.